Our next language for discussion is the following: a power n, b power m, where n is strictly less than m, and n comma m is this. What this says is, if you look at sample strings, if it is a, b is strictly more, so which means a b b is valid, or a followed by b b, you can have any number of b's. So you can have a followed by at least 4 b's. Fine. So you can also look at this language like this: a power n, b power n, and b power k, where n is at least 1 and k is also at least 1. Correct? So this tells you that number of b's read is at least 1 more than number of a's read. So this part m is precisely n plus k. So you can mimic the automaton what we described for a power n, b power n, then followed by how do we handle this part. So this essentially tells you the following: the behavior of automaton for this language is similar to a power n, b power n. The difference comes only at this part. Correct? So let's look at this string, say a followed by 4 b's. Now AB is valid, and then we get to see this part, which means if you mimic the behavior of a power n, b power n, stack will be empty, or stack will contain z0 at the end of this configuration, and then we get to see input tape is not empty. Input tape contains a couple of b's. So that shows that if you are in a state where you have completed scanning a power n, b power n, and you are reading a b, and top of the symbol is z0, which means you can accept. What does that tell you? We are reading at least 1 more b than at least the b that we have read is at least 1 more than the number of a's read, right? So what we read is at least 1 more than number of a's read. It's a valid string and we can accept. Okay, so let's describe this formally. So delta of q0 comma a followed by z0, we say we go to q1, push capital A z0, and when we are in q1 we read this, stay in q1 and push. Now at this point in time we read a b, and top symbol is this, we say perform pop, q2 comma b comma capital A, we say pop. Now we are in q2, we read a b, top symbol is z0. So what is this telling us? If you are in q2, which means you are reading b's corresponding to A's read, and then you have completed popping couple of B's. Now you are reading a B. Top symbol is Z0, which means A power n, B power n, such a substring we have seen in the given input. So when we come to this configuration, which means we have read until this part. So A power n, B power n substring in the given string is read. Now I am reading a B, which is one more as per our specification, which means it satisfies this as well. So we say accept. So QF, comma, we don't need to know how many more B's will come after this. Even if we see one more B, we are done, because it only says number of B's is more than this, and how much it should be more, all that is not given. Correct? The moment you find one more B than this, we accept. So we say QF, comma, Z0, we accept, or you can also do it by emptying the store. Fine. But remember, when we stop the automaton, the input tape is not empty. You still have some more symbols in the input tape, and we don't scan the entire input tape. Okay, because the moment you see a substring which is valid, we accept. Correct? Okay. But one has to be careful with this part. For example, what if the input string is AAA followed by 4 B's and then maybe a couple of more B's. But after that, what if you have 2 A's? You get to see that this part is valid, but suddenly at a later part you get to see there is something called AA, and we say this part is like A power n, B power n, and the moment we see one more B, we say we accept. But one has to be careful. We should read this tape completely and ensure that it is all B's, and before we conclude that it is valid, before we reach the final state by emptying the store or not by emptying the store. So just seeing one B and taking the automaton to the final state may not be the correct one. Fine. So we should ensure that we read the entire string, and with that one can check whether the rest of the symbols in the string are B or not, and if they are all B's, you stop, accept, otherwise one has to reject. Fine. So let's modify this accordingly. So when we reach this, what we do is the following. We continue to stay at Q2 and scan through all B's. Something like a self loop. You are at Q2 and you read B comma Z0, you stay in Q2 and do not change the stack. Again you see a B, you read and then go to the next B. Read a B and stay there, go to the next B. So like that you keep doing it, and after some time you see that you are in Q2, input tape is exhausted and top symbol is Z0. Now we should accept, it's a valid string. So this construction tells you a strong message that when you construct an automaton, one has to be careful that if you are looking for a specific pattern like A power n, B power m and so on, unless you exhaust the tape, unless you scan through the entire string, you should not take the automaton to final state, or you should not accept by emptying the store. Okay, because if you read a after this, then we run into problem. So if this is your specific pattern, then we should not have anything after this. Fine. So one should always ensure that the automaton input tape is empty in case we are looking for a specific pattern. If there is no pattern, then no constraint on whatever we see after this, then you can accept even if you do not see the entire input string. But often we design machines satisfying specific constraints. So if that's the case, automaton can reach the final state, or automaton can accept by emptying the store when it has exhausted the input tape and see the top symbol, which is Z0. Fine. So now, as always, in case you read a B at Q0, one has to reject. And similarly, when you are in Q2, you read A and top symbol is Z0, it should be rejected. Fine. So if you focus on the transition diagram, it says Q0, and when you read A, top symbol is Z0, that is replaced with A Z0, and we go to Q1. When we are in Q1, when we read small a, top symbol is this, then we replace that with this. Okay. You can also write like this, a comma like this, which means this is our input symbol, top of the stack, and it is replaced with this. Okay. So because we use small letters for sigma and capital letters for gamma, even if you don't put a comma, it is understood. Then at Q1 we read a B, top symbol is A, and we say you pop and then go to Q2. At Q2 input is B, top symbol is A, and then this. At Q2 you get to see B, top symbol is Z0. We simply scan through all of them and we do not change the stack. And at some point in time we exhaust the input, top symbol is Z0, you say Z0 or epsilon and reach the final state. Okay. Or you can also stay in Q2 and empty the push down store or stack. And as always, there will be a state called QR. The missing transitions will go to QR. Fine. Let's look at a couple of more case studies and discover more about push down automaton. And subsequently, we want to understand the limitations of this machine.